A bird flies from a tree. At time t seconds, the bird's height y meters above the horizontal ground is given by this equation here, for t between 0 and 4. Find dy dt. Find the rate of change of height of the bird in meters per second when t equals 1. Determine with a reason whether the bird's height above the horizontal ground is increasing or decreasing when t equals 1. Find the value of d2y by dd squared when t equals 2. Given that y has a stationary value when t equals 2, state whether this is a maximum value or a minimum value. So I think I need to put part 2 down here. Is this a max or min, wasn't it? We might flick back to that one when we come to do that part of the question. So we've got the question summarized here then. Find dy dt. Here's y. So let's get dy dt first of all then. Okay. So differentiating with respect to t. So treating t like the x symbol, power rule, 4 comes down, 4 over 8 is a half. T to the 1 less than 4, which is 3. Minus, the 2 comes down, 2 lots of t to the 1 less, which is just 1, which is just t itself. And the constant goes to 0. So there's dy dt. Find the rate of change of height when in meters per second when t equals 1. So b, part 1, t equals 1 then. Rate of change of height with respect to time is dy dt. Put 1 in here. Half times 1 cubed minus 2 times 1. Half minus 2 is minus 1 over 1.5 meters per second. So the height is y, so it's moving, that's a negative velocity, so it's moving down, isn't it? When t equals 1. Determine with the reason whether the height is decreasing or increasing. Okay, part 2. Since dy dt is less than 0, the height, because it's above the ground, the height is negative, so the rate of the velocity upwards is negative, so the height is decreasing then, isn't it? Because it's going downwards. Or it's going upwards with a negative speed, which means it's going downwards with a positive speed. So part C. Find d2y by dt squared when t is 2. So differentiate once again. Use the power rule. 3 comes down to b with the 2. 3 over 2. T to the 1 less is 2. Minus 2 lots of t differentiates to 1. Minus 2 lots of 1 is just minus 2. Which equals times 2. When t is 2, put 2 in. 4 over 2 is 2. 3 2s are 6. 6 minus 2 is 4. And this is meters per second per second. The acceleration is now upwards of 4 meters per second per second. Is this a max or min? Well, it's positive. It is a turning point, we're told, when t equals 2. Is it a max or min? Since d2y dt squared is positive, this would be a max. Is a min. Make my mind up. This is a minimum. There we go, because the second derivative is positive at t equals 2, which we're told is a turning point. Let's just click back to the question to make sure we've done that. State whether this is a max or minimum value, so we just have to state.